All right, when it comes to solving rational equations, you are going to need to find a common denominator. Now, these two expressions have the same denominator, x minus 2. However, this one's different. So the first step is factor anything that needs to be factored. So this x squared minus 4, that's a difference of squares, but you can also think of it as x squared plus 0x, because there's no x term, minus 4, and look for things that multiply to give you negative 4 and add to give you 0. That would be 2 and negative 2. So this becomes x plus 2, x minus 2. So we have 1 over x plus 2, x minus 2. Then we have plus 1 over x minus 2. We don't have to change that one. And 6 over x minus 2. All right? So what is our common denominator? Well, it has to include every denominator. So if I look at this one, I know I need to have x minus 2 in my common denominator. Or, I'm sorry, yeah, x minus 2. I need x minus 2 in my common denominator. So that takes care of that one. It's covered. This is included in that. This one, I'll do with a squiggly line, x minus 2. I need to check and make sure that's in my common denominator. Yep, it is. It's there. Right? So that one's done. And then over here, I need to make sure this entire thing is included in my common denominator. So I need all of that to be in here. Now, if I look, I have the x minus 2, but not the x plus 2. So I have to put the x plus 2 in here. And now, if I compare them, this denominator is included, this denominator is included, and this denominator is included. So this is my common denominator. Of course, from that, I can get my domain restrictions. I have x plus 2 not equal to 0, which gives me x not equal to negative 2, and I have x minus 2 not equal to 0, which gives me x not equal to 2. So my domain restrictions are x not equal to negative 2 or positive 2. Right? But to actually solve it, I need to go back up here and multiply everything by that common denominator. Both factors. All right, so let's look at the first fraction. If I have, separate that off. If I have 1 over x plus 2, x minus 2, and I multiply that by x plus 2, x minus 2, everything cancels out, and I just get 1. That's actually why we multiply it by the common denominator, because all of our denominators will magically go away. Okay, then I have plus 1 over x minus 2, and that, again, I'm going to multiply by x plus 2, x minus 2, and my x minus 2 will cancel. So I have my 1 from my first fraction, and then here I have plus 1 times x plus 2. And then finally, if I look at the other side of the equal sign, when I multiply these, again, my x minus 2 will cancel, and I'll just have 6 times x plus 2. And now this is no longer a rational equation. This is a much easier equation to solve. I need to distribute the 1 over here, and I also need to distribute the 6 right here. So that becomes 1 plus 1x plus 2 equals 6x plus 12. Now I want to get all my x's to one side and all my numbers to the other side, but first I need to combine like terms. So this is 1x plus 3 equals 6x plus 12. I happen to have a positive x on the right-hand side, so I think I'm going to move my x's towards the right-hand side. It doesn't really matter, but I'm going to do that, which will cause this to go away. Over here, I will have a 5x. All right? I have my equal sign. Now I want to move my numbers to the other side, so I'm also going to subtract 12. Now, 3 minus 12 gives me a negative 9. Divide both sides by 5 to isolate the x, and I get x equal negative 9 over 5. Before I box this, I just have to check and make sure that this x is allowed. So I'm going to go back and I'm going to say, okay, x equals negative 9/5. Is it allowed to equal that? So I go back to my domain restrictions, and I see that the only x values that aren't allowed are negative 2 and 2. I don't see negative 9/5 on this list. So this is good. So this right here is my answer.